kind of mathematical equations which will give some output. So it is bit important for all of us to understand the basics. Nowadays, even no-code platforms are there, so anybody can use any simple platforms to do this experiment. But the theory behind this is very important, and especially some developers joining this forum, they ask this question: how a computer program memorize what they have trained or what they have seen as images and apply it in the future for classification or identifying objects. That was the major challenge for us to understand that. If there's any question, you can interrupt and ask me any questions. So I will try to explain this concept with the very basic thing. No need any prior coding experience here, or you don't need to have a thorough mathematical understanding in order to understand this concept. So we'll try to build it very beginning level, step by step. So I think you all can hear me and you all can see my screen as well, right?
Yes, we can.
Okay, great. And I appreciate if you can ask questions, and this should be a kind of a interactive session, and otherwise it is very difficult for me to understand your level. And I am planning to give you a kind of a hands-on experience in this exercise so that at the end you will get some knowledge. So after completing this exercise, I will give you a practical real world sample so that you can run it leisurely and share with me the output so that I will certify that you completed the course. So as the last lesson, this is important. So I will try to introduce you to the CNN. CNN mean it is a name of algorithm. Don't worry about the name. Convolutional neural network is the name somebody has given. So actually, it is very old theory. In 1988, Yang Lucan, a guy who was working in Facebook those days, tried to come up with this idea and find as a result today we use it in many different practical scenarios like even auto drive cars and identifying object in medical fields. So many things happen after this theory came. So we will try to understand what is this CNN or convolutional neural network. If you see my screen, you can see a picture of a bird. So in this algorithm, we have mainly, we can say simply three different layers. One is input layer. So the details of this image will be given as the input for the input layer. Then we have a hidden layer. I will explain the details. And then we have output layer. In the output layer, we can identify whether it's a bird or animal, something like that. So think always when a small kid who have never seen a bird, how they learn. First day, somebody tells him that this is a bird. Then he identify his the nature, like he has feathers, then feet and eyes, etc. He observe like that. Next day when he see another bird, he can identify it. Same way, this model is also trained with different algorithms, and it recall, okay, I have seen it somewhere and it is a bird. Like that, here it is specially for classification problem. It categorize, okay, whether it's a bird or animal, something like that. So especially in CNN, we can see three different layers. One is input layer, then the hidden layer, then the output layer. So if we take it further into detail, like here in this example, we can see a small dog, then we send it into a convolutional layer. So in convolutional layer, we have convolution and pooling both. So I will explain what is convolution. Then it is sent to the fully connected layer. Then this connected layer is all about a neural network actually. So it can behave in a different way. I will explain it further. And then the output, it classified whether it's a dog, cat, or mouse, something like that. So practical usage of this kind of a neural network, we can see mainly in image recognition, image classification, then object detection, face recognition, etc. Now, so basically, the first convolution layer we use to identify features. Now you have two examples. In the previous example, I got a bird, but here it's a small dog. So dog has different kind of observable ears and different features. So then these features we try to remember in our algorithm. So how do we come up with the solution? Like here, when it comes to images, it is not very simple. So even though it is a small image, you have seen that in the image, we say if it is very good quality image, we say it is high resolution image. Resolution is measured from DPI, dots per inch, something like that. So if the DPI is high, let's say if the DPI is 1800, then that's mean it's high quality. That's mean it has lot of features. In the image, it is not only one layer. If it is a color image, it has three layers: RGB, red, blue, and green. So in this case, if the image size is, let's say, 150 dpi, then width is 150, height is also 150. So in that case, it has three layers, 115 to 3. So it has different colors as well. So remembering all these small points will be a very challenging task. So little by little, we will try to understand how the CNN model keep all this information in its memory. How do we do that? So I will explain it in a simple manner. So I will try to match these algorithms with real world examples. So especially if you get this number, it is not that much complex. So it is also kind of an image we can scan from a printed book or handwritten document, and it will be converted into kind of an array first. So I will explain it further how it is happening. So I am trying to tell you these images will be difficult to remember. It has no actually brain, but we have to come up with the algorithm how to train a model that this is a number, number 8, number 7, like that. Digit should be recognized, letters should be recognized, similarly object should be recognized. So asking it to remember all the pattern is very challenging. What we have done in these algorithms, simply we convert it into arrays or things like ones and zero here. So this 8 we divided into 25 small rectangles, and black color rectangles are marked as 1. So here you can see 8. If you carefully look at this, 8 is there, and it is a kind of a numerical representation. So here it will be little bit easy for a model to remember that each rectangle is allocated something like this, but it is still very complicated because this number 8 may be in a larger picture, probably it may be in a smaller picture. Sometimes if it is handwritten text, 8 may be different. Sometimes people not draw 8 in the same way the next time, but still we should be able to categorize and put it into different buckets. So we are trying to develop a kind of a logic here, how we need to keep all the details about the features. So when it comes to this number, it has features, and the previous picture also, it has different features. So we are trying to keep everything in a kind of array. This is kind of array. It has numbers. So in an array, we call 2D array. It has width and height, let's say in simple words. So we are trying to keep everything in an array in a numeric format. So that what we can do, if we can keep all this information in this manner, one day in future, if after training the model, if we recall something, it is easy for us to search one by one. Okay, let's say we search in the first cell, then the second cell, like that. If there's any missing item, still we can draw number 8 and we can identify it as number 8 letter, something like that it works. So then here it is a simplified version. So even in our real world scenario, it is 3 layers color images sometimes. So it is more complex, but I am taking it as much as possible simplified. So here it may be this forward slash, this may be a backward slash, so that these simple images can be trained very easily. So if it is coming the pixels as this manner, then we can represent it as this. If it is coming as this, we can represent it as like this. So this is the simplest version. But when we discuss about some complex thing, we have to again draw a simplified version. Here, these curves, etc. At least we have to draw it in this manner. Otherwise, we can't memorize it and recall whether this is correct or not. This is very basic example. So like this, we are trying to come up with some numerical arrays. Like simply, we should be able to come up with a set of numbers. So whenever you give a similar image, it will convert again to a number, and from the trained data, it will be matching which one is going to be the most close match for this new object, and it will be identified it automatically. We call it a classification. So this CNN model also works like that. Not only CNN model, there are so many new models coming, but I am trying to explain you some basics. So this convolutional neural network mainly has 4 layers actually. One is convolutional layer. That is the first one. Then the second one is rectified linear unit. We call it in simple terms. Then the pooling layer. Then fully connected layer. I will get one by one. The most important part here is that convolutional layer. It will help a lot to identify the features. Then fully connected layer, it is a different thing. It is common in most of the machine learning algorithms. In fully connected layer, simply we can say in general, forget about what we are going to discuss now, and in general, what is this machine learning? In our university or in our school days, what we tried our best to substitute something for a formula. In the university, we get or maybe in schools, we get a formula. Let's say S equal ut plus at square. So that is the equation for uh, something like distance with velocity, etc. What we were given all the different speed, time. So we were asked to calculate something, what is this and what is the distance, something like that we did. So that is what we substitute the simple values into an equation and we found the answer. So that is the very basic thing. Think about the person who found that formula. That is the guy. He's the most genius guy, because nobody found equations very frequently. Nowadays, even we don't hear. Isaac Newton found a lot of equations. He found gravity and a lot of equations he found. So here with machine learning models, what we are going to do, we are trying to find equations. So we collect lot of data points, and if we draw a data point in a graph, probably after drawing and connecting all the data points, we can come up with the formula. Some data point will not be fixing perfectly, but still we can come up with the graph. So in this fully connected layer, it is happening like that. Lot of variables we can give, like for example, y equal mx plus c. That is very basic linear equation. So in that kind of a linear equation, the variable x is called a independent variable. So when we change the x, y is changing automatically. So in that exercise, in the schools, we were asked to find y given the x value. But here, what we are trying to do, we are getting only data. We don't get a formula. So through this connected layer, we are trying to find a formula. So ML model can generate formula. So when we see a model, it is like storing all the data with regards to a formula. When we talk about a formula, think about a formula like this. I will open this one. Think about a formula like this. Then y equal a, sorry, maybe many x variables, not only one. So in our this practical scenario also, there may be many x. I am referring to x like not simply anything like yeah, a3, x3. Like that, there may be many x variables. So the challenge here is that x variables are like the free or the eyes or ears, like that. We will be giving different small parts of a feature to this kind of a formula. So we have thousands of images. So from these images, we are trying to collect different x values. But A1, A2, A3, those are variables which we don't know. Finally, what we are going to do through this training model, we will be trying to give some values to A1, A2, A3, which should be very justifiable or very generic to all different data points, so that in future, if we get a new one, then A1, A2, A3 will be there in our formula. That is what we call a model, something like that. Then using that model, future, let's say, chest x-rays, we can check whether that guy has a what do you call pneumonia or not, something like that. We can do even with our naked eyes. For doctors, it is difficult. It may not be very difficult, but for normal people, definitely it will be very difficult because we can't read the details. Sometimes we may miss that, and like that kind of exercise we are going to do. So through this exercise, I wanted to explain you that here, this last one is very important. It is fully connected layer. The other ones are like we are trying to extract the features. The last one we are using to come up with the formula. So I will try to explain. Can you please confirm whether you all can hear me? And if you have any questions, you can ask me. At least confirm through chat whether.
Yeah, we can hear you.
Okay, thank you very much.
Yes, we can hear you.
Okay, great, great. Am I explaining it very clearly, or do you think that I need to go a bit?
Yeah, we can understand. We can understand.
Because today I am going to give you a kind of a summary so that you will understand any difficult situation. I am not going to teach you very tough codes or mathematical lessons here, but I am trying to give you the basics so that nowadays lot of tools like ChatGPT, etc. available. Even the code, I need you to search yourself and try to come up with simple example so that we can work together. Probably some of you guys will share your screen and we'll do it like as a team or maybe practical session. So here, I will then, now I started explaining about the last one. It is fully connected layer. So that is common in any machine languages models. But when it comes to convolutional operations, this is very specific. So we will see how we are going to interpret this data into a kind of a recallable, or I can say reusable way. Now here the challenge is that if you see some of these images, we came like this. Here we try to convert it into a numerical form, but this is also not very easy because it is not very simple like this. When it comes to our practical scenario, it may have more than 150 by 150 images sometimes. So here we are trying to come up with a very basic algorithm how we are going to convert these details or features in the images into a numerical array or numerical numbers, so that we will be able to check whether this number is like if you are going to give a new data point or new image, it will go back and check all the previous data and it will identify, okay, this is belong to this particular category, something like that. Especially, I think this will be very useful. I took a very simple example, this pneumonia X-rays, but when it comes to cancer images, etc., I think 10,000 different cancer types should be there. So in that case, even human can make mistake. AI model we can train the way, if you understand it is trained, then you will understand how we need to select sample, how we need to label it, and what is the benefit, what is the pros, cons, etc. You will understand. Everybody is telling nowadays AI is not going to work and it has a lot of limitations, etc. But if we have the basic understanding, then we can take some intelligent decision. I'm thinking in future, most of the things will be changed because these algorithms are also changing. Whenever we get some algorithms like Newton laws, etc., still we believe that is the most important thing, and we learn it in the university schools, but still it is continuing. But in this industry, these models are changing very fast. I remember when I start my final project, the algorithms were not there, some of the algorithms, but the supervisor panel advised me that there are new algorithms. When I searched, I found that during last 5-6 months, it was changing very fast. So then I had to redesign my experiment as well. Like that, it is changing. These algorithms are not very written, and it is not permanent, and another algorithm will come and it will be more intelligent than this one. So don't try to memorize these things, but try to understand what is the logic behind this. Okay. I will take this as a very simple example. In my image, let's say I have a plus sign here, right? Plus sign here, all black color cells I mark with 1, and then the other cells I mark with 0, then this plus sign. So in convolutional operations, we identify different filters. So this is a kind of a filter we introduce in order to catch up different sizes, different angles, etc. So if it is a tiger, probably sometimes we find is colors and some features, maybe tail, in different angles. So to to rep, to represent everything, we apply a filter. So this filter, maybe we have different names. Don't worry about the name, kernel filter, etc. We use. It is not very complex like this. It may be most of the time one something like that. So this filter we use, and from this filter we are trying to create a new image. That image is similar to this image, but it may have some variations. So what we are going to do, if we overlap these two, we call this as a let's say matrix. So if we overlap this and if we multiply these two, like here I get 0, again multiply by 0. Here I try to overlay these two. So I take this one and put it on the top of this one. So what I am going to do, this one I multiplied by this one I multiplied by this one I multiplied by this. So 3 into 0, it's 0. Then 2 into 1, it's 2. Like that, I come up with a new number, and finally I add everything. When I add everything, the number comes as 12 here. So this whole set now become this 12. So it is a different way, but this filter is common, but I took this as a simple example, but this may be a part of a big image. So this may be only a maybe freak of the bird or something like that, a small part here, but it may have another item. So we apply the same into others as well. This filter we apply. So when we apply the filter, this one will be multiplied by this one will be multiplied by this one will be multiplied by this one multiplied by this, like this. So finally, when we add everything, we can come up with a simple number. So I'm not going to tell that whenever it identify this kind of thing, simply it is identified 12 is for the free or something like that. But it has some closer thing what we are searching. We are trying to simplify this. So in the image, thousands of this kind of features will be there. Those features we are trying to represent from a simple number. So this number will be working like x1, x2, x3, like independent variable there. So this is what we do in convolutional operations. So we apply another filter here, and we are trying to come up with the number like this. So then what we are going to do, here this is a bigger picture. So this is kind of a filter. So it is called kernel filter. This is very famous one. So what we are going to do, we are trying to come up with this convolutional layer so that we can apply this filter on the first part first, then this part, then this part, like that. The middle we put the total. So we'll try to understand that. So as I said earlier, okay, here if we look at this one, okay, I overlay this one, this filter on the top of this one. So then 0 into 1, 0 into 1, 0 into 1, like that. Here you can see 0 into 1, 0 into 1, 0 into 1. Then here 0 into 1, 1 into 1. Here only we can see 1. All other these are 0. So here I am going to find a number instead of everything. I am trying to get a number here. So if you see this one again, here 0 into 1, 1 into 1, 1 into 1. So same way, here you can see 1 into 1. And for this column, now after summing up everything, we can come up with something like this. Here it is 0.3, but the total comes as 9. Since we have 9 columns, even we can divide it by 9. It won't make a big difference. So average number we can get here, so that we can try to simplify the features here. So that is the objective. So then this part is okay. Then I think you will understand what I am telling, right? We apply a simple kernel here, and we are trying to get a number here. Finally, for this particular image, we are going to get a kind of a set of numbers for different features. So you understand, it may be for tail, it may be for freak, it may be for feathers, it may be for eyes. Like that, we are trying to identify and separate these features by applying these convolutional filters. We call it kernel, different names are there. But here, what is the filter we applied? We applied this filter 111, like 3 by 3 filter, 1, right? So like that, we fill this first one. Then we'll go to the second one. So we shift one column here, then we apply the same thing here. Again, this one, when we calculate, it comes like 0.4. Like that, one by one, we calculate everything. And finally, we could come up with something like that. So the one benefit here is that then it is coming like very closer. If there's a big gap between the object and the other background boundaries, etc., we can come to very specific area. Now these numbers are there. I got a kernel and plus only, but there may be some minus values also here. If there are some minus values here, it may be minus values as well. It is possible. So then this is what we call convolutional layer. So finally, instead of that 8 or something, we come up with some numbers like this. So it is clear. Then what we are going to do, it has padding. Even we can add padding. So earlier this was the original image and there may be some cut images or something like that. If that is the case, we can add the extra layer also, and we can again calculate applying the filter. Here we apply the filter and we see whether something is happening these areas also, so that we can get a more reasonable one. So forget about that padding layers. In some cases, it applies padding also, but in our cases, everything is 0. So it will not have a big impact there. Then we'll come to this point. So this is called another layer, relief. So rectified linear unit. So this is another kind of layer which we are trying to further simplify that. Say, for example, if there are minus values, we can forget about that, and only plus values we will be taking into consideration. So we can apply relay like this. There are different rectified layers as well. So we can use this one and we can further fine tune. I will explain it further. So we are trying to come up with something like this. So now this was the original convolutional layer we came up with. Then after applying this relay layer, it will be further fine tuned. Here, for example, it has some color features. Now we are trying to identify features here like this. So after applying this filter and prelude layer, then it will be further simplified. So then there's another technique called pooling layer. What we are going to do, we divide it into maybe 4 by 4, sorry, 2 by 2 another filter, and we are trying to get the maximum. Average also we can get. Here, if you consider these 4 cells, maximum is 6. If we consider these 4 cells, maximum is 8. Here, maximum is 4. Here, the maximum is 7. Now, this is further simplified. So, here, through this pooling layer, we call, through this pooling layer, we simplified it further. Earlier, it was 16 cells or square picture. Now, it is 4 square picture. Now we see little bit easier to check whether these are going to work with the new image. When we give a new image, again we apply same thing. Here first convolutional layer we apply like this, and we try to new with regards to new image. Now we talk about training steps now. With the new image also we apply the same thing. Then reliable layer we apply the same thing like this, and if there's any minus figures, we forget about that. Then like this, after reliable layer, then we apply a pooling techniques here, pooling layer, so that it comes like this. So then it is little bit easy for us to check these numbers are tally with the previously trained images. So if something found equally perfectly match, then we say, okay, this is a bird, something like that. This image may contain the details of pneumonia, something like that we are trying to understand. So it is not simple as I am explaining, but here this is the concept. So then after applying pooling layer, it will be further simplified. Even the picture comes like this. So it is kind of a black and white, straightforward. It can identify edges, corners, bodies, feathers, eyes, beak, kind of things now separated into different filters. So these are different different features we are trying to identify, trying to distinguish between different features. Now, if you see this one, okay, usually these hornbills we can see everywhere with the long beak like this. So we identify them. So then there's another technique called flattening. Flattening mean this one we arrange it in a kind of a, again, array 6, 8, 4, 7, 6, 8, 4, 7. This is kind of a two-dimensional array. We can convert it into a linear vector like this. We call it vector. Don't worry about these names. So finally, that hornbill became into a number, right? So now I think you may have a better understanding. So I will switch to another practical example. When we develop a system, usually we give kind of a identification number. Let's say we need to store all patient data in a database. So we use either their NIC number or some other number in order to easily search that. Very similar to that here also, for different pictures like different objects, birds, lions, bears, etc. Now we have a number, but it is applicable only for the first image. There may be thousands of images. This number may be vary, but this number, it will not represent any numerical value. But let's say if we find another one, another similar hornbill, but its number is 6947. 6947 is very close to hornbill, so that we can just predict that it should be a hornbill. If this number is let's say 5,000, 9,000, 11,000 and 7,000, something like that, it may be a feature explaining about a lion. But when we give more and more data, it will be averaging and it will be giving more accurate answers. So that a machine language model can use this kind of vector, linear vector, to search something fast and identify it. So even nowadays, self-driven cars, it process very fast because those are in vector format. In vector format, even we can think of thousands and millions of thousands of filters, millions of data. We should be able to search fast through these kind of mathematical approaches. So this convolutional approach gave a different picture to our AI related development. So this is how it identify those objects. So it is not kind of a rule based one. We can't give a specific rule. Okay, if lion has a uh, uh, maybe long tail, then we should not say with the if command, okay, lion has a long tail and cat has a small tail and bushy tail, something like that. We are not going to write it, but through training process, it will be updating thousands of these images. Now this belongs to that hornbill. That kind of hornbills, there may be thousands of hornbill pictures. So then it will be collecting everything like this. So now we'll try to understand this one with connected layer. Earlier, I tried to explain the next one is connected layer. So now these features are kind of X variables like X1, X2, X3. so that we have a set of data with us. So a large set of data. So what we are going to do now, we can't even think about four-dimensional graphs, but at least we can think of a two-dimensional graph now. So we were given some details like here, this hornbills has 4 features. Let's say first 2 features, I don't know what feature it is mapping, but anyway, these first 2 features, if we put into a graph and if we try to find a formula to identify hornbills, that kind of mechanism we are applying through this machine learning full process. So as the connected layer, it will take input as all these numbers like x1, x2, x3, x4. So it tries to build a formula. Now, this is fully connected layer. So first part, as I explained, input image, then conventional layer, then it identify whether minus values, etc. are there. So then pooling layer maximum value we get, then try to rearrange the numbers. Then we apply filters, and then we apply fluttering, and after that 16 cell became like it was like you remember that, I believe. Anyway, I will show you that again. Here, this is flattening. So this layer become like this number. So before that we had pooling layer. Here pooling layer, these 16 number cells became 4 numbers. So applying all these techniques, don't need to remember all the names, but try to get the concept. So finally we have this kind of a linear vector. So now here, this linear vector will be the input to the fully connected layer. So this is a kind of a fully connected layer after pooling, after flattening. Then this fully connected layer we use to extract a formula. That is the thing. So I think I explained everything. If you have any question, you can ask now. And I think here there are a couple of experienced guys in machine learning also. So if you have any question, you can ask now. Can you all hear me, or do you understand something, or do you?
Yeah, we can understand. Yes.
So I'm trying to explain this because these fundamentals are very important. Now you know what we can do with machine learning, but if you have some fundamentals, I want now you need to try yourself. Nowadays, ChatGPT, etc. are there. So I got some feedback from some doctors as well. They tried themselves, and I don't want to keep anything with me. And coding, it's nothing nowadays. As long as you can write English, you can code anything. If you get error message, you can ask what we can do, so that it gives correct resolutions as well. So up to this, is there any problem? Even some of my students are also here. So if you have any questions, you can ask. This is kind of a practical scenario, practical forum, and I tried my best to explain this because most of the people, by searching in the internet, they can't understand this. And what is this x1, x2, x3? What is this formula we are talking about? In schools, what we did, we tried to substitute the values for a formula. But now with this AI, people like Isaac Newton, there may be more Isaac Newtons with AI support. Nowadays, people can come up with different formulas very easily. So even the first formula we learn in the school is that for a circle, the length of the outer circle is 2 pi r. So we did experiment those days. Simply with the paper, we tried to draw different rectangles, and we divided it into small pieces like rectangles, and we turned the other side, and we pasted the kind of another rectangle kind of a thing, and we try to understand the length, etc. Like that, we got the basic ideas those days, but we were not that much interested. But nowadays, even people can come up with more things, like even uh, rectangle, the what do you call the base the karne varge equal pada deke varge, something like that we learned from Pythagoras theorem. So nowadays those are very easy, and Pythagoras found that. But even now with AI we can do that, because what we need to do, we need to get some data, draw some rectangles, and try to get the length, etc., and give these three figures, and then AI will give the formula. So finding formula is no more challenge. We need to give data and it will generate a formula. So through fully connected layer, we can get a formula. For fully connected layer, the name is specialized in this CNN, but this kind of neural networks are there everywhere. So this is the basics, but I wanted to explain you. So others, if you all can contribute and ask questions, I think we can continue this in a very efficient manner. If you have any questions, please contribute. Even I see.
So if you are this explaining for this fixed images, if the images is continuously running like how do we do it? Like you get the fractionate of images, or it's like that?
It's a good question. Actually, now you are asking something like video, right? So
Yeah, continuously, yeah.
yeah. If you train something like video, again, if you go to the route of creating a video, inside the video also there are images. It's a images. We see it as a running video, but nothing running there. It like whenever we get a high quality video, that's mean the speed is, or the number of images stored in that video is very high. But if we are getting very low quality video, that means the number of images are less. So video is also generated through images. So finally, when we even give the video as the training input, the AI model can separate it into small uh, images like this, and it is working same as I explained. So there's no difference. Finally, even when you look at the image, you think that is a picture. That is what we have written in our mind for a long time, but that is not a real picture. It is a set of small dots. Each cells has different color set. That's it, right? Like that for images also, it is not, sorry, for videos also, it is not a video, it is a set of a collection of images are there. So we are trying to understand the basics. So it's a good question, and ask those kind of question. I think Bimalka, some new guys are also here. You also can ask questions.
Then what about sound? Now we can dictate something and it type in the screen. Is it similar thing in reverse manner?
Right, okay. Actually, convolutional neural networks are not going to use for especially sound, etc. But if you carefully look at the final layer, the fully connected layer, or this one, even sound you can manage in the same way. Like here, I was trying to explain for these input layers, even with the sound, again, if you go to the basic, it has like peaks and different features there. So here, if we can get those details, we can like, if it is sound, we can identify the different features again.
Yes.
For x1, x2, x3, we will be filling here, and it will generate a formula, and it will categorize into different buckets here. So if it is kind of a wave, then CNN convolutional neural network you can use. But for sounds, there are different algorithms. It will capture X1, X2 kind of a feature there. Maybe, I don't know exactly, maybe even we can search it in sound also, it's different. Like, I don't know exactly frequency or any other thing, we can identify as different features. So we can give all the inputs like X1, X2, X3. You need to identify independent variables.
Okay.
So many resources are there. Even I don't know everything, but you can search, you can ask questions. Now the era is different. In our school times, we were taught, even we all were taught, remember something and apply it in the exam.
Apply it.
That is totally outdated now. Even in our education system, we need to change now. We need to train student to ask questions. As long as you ask questions, then you get answers. Now the GPT model and everything is available. What you need to tell in English, you need to ask the questions. If you don't ask the questions, then no answer. So it's good asking questions. I think I explained it clearly, and even you can do further research on that.
So do they remember in the sense memory also similar, or you have explained clearly how the visual images analyze and understand? What are the memory part? How do you remember?
It's a good question. Even you will notice, I will show you that in my exercise also, you will notice most of the people, they think that whenever we train with millions of different data, our model is becoming more and more bigger. But I told you that it is not memory. Finally, it is fine-tuning the formula. I will show you the model, which I'm going to save in the next exercise. So you all can practically observe that. That is kind of a wrong idea. It will not keep everything in the memory. It simply come up with the formula. From the model, I will show you a model here. I tried to run it earlier. Let me try to show you that. This is, sorry. Give me a second. I will show you a model. Then you will understand in that model. From where can I get it? Okay, here, let me check. Here, this is a model. You can see .h file, right? So I uploaded all the images. I will download this model file. So I will show you, it is a small file actually. Let me try to find. You will also get this one. I think there's a problem in my connection. So anyway, this is a small file. It contains the details of the formula. So you remember that I tried to explain you here. This kind of formula, it will be tried to generate through this all feature list, which I tried to give it to. Feature list mean X1, X2, X3. So this A1, A2, A3 details are stored. Not only these details, some other details are also there. Are stored inside this particular model file. This is a train model file. I will run and I will show you how it is working. Let me. Anyway, you will get a chance to run it. I will run it again. So I don't know why it is not downloaded. Okay, it came here. You can see, even though I gave a large number of images, it was a small file here, right? It is only 56 KB. Even it is not 1 MB. It is a small file. From this file, the formula is written. The best formula. The formula also, I will show you how it runs. It is not simple thing. Even with one image, it runs 50 times, right? I can specify the number of times it should run. Here I will go to the code and I will show you. We call it epoch. You can see it. I will give you this code and I will explain one by one. So one image will be running many times. So then it will be, I have specified something here. Okay, here 50 times. So that it tries to recorrect it. Here this formula first. Now whenever it runs, for example, Y mean the classification, hornbill, something like that. X1 mean it's feather, eyes, tail, something like that. All details we will try to run. When we run 50 times, first time A1, A2, A3, it will give some values. But when we run many times, it consider the previous data as well. It will be fine tuning again and again. So first time A1 will get value minus 0.005. Then second time it may be minus 0.002. Next time it may be minus 0.125. Like that it is changing. So it try to find the best formula which matches everything. The formula mean, think about a graph where we can draw everything like x1, x2, let's forget about x2, x1, x2, x3. If we draw a graph like this, let's say 3D graph like this. So this is y. This is x1. This is x2, right? Here in this graph, if we mark something here, then it has different A1, A2, A3 components here. Then some items are coming here. Finally, when we run everything, this may be a lion, this may be a hornbill, this may be a dog. So everything comes like this. So some dogs are coming here, some hornbills are coming here, some lions also can come here. So finally, in a space like this, it is not only, now here we have independent variable 2, but it may have independent variable 168, 164, something like that. So think about a situation like that. So coming up with a formula like this is not easy. So it is like whenever it runs 5 times, 5 images, it reads. So from the 5 images, it try to give some values to A1, A2, A3. Then when it comes to another one, again it will be running 50 times. So it will be changing these values and see whether which one is going to work. Like we need to have a common formula for everything, no? Right? So Y mean that is the output. That will give output like in numerical values we get 1 is for hornbills, 2 is for lions, 3 is for birds, something like that. It can identify. Finally, we can interpret it later. But here from one formula, we need to identify everything. So now very similar to this, large language models are also trained in the same way. So it can identify not only the particular word, but it can identify sentence as well now. And if that sentence is related to political law, that sentence is related to sports, like that, it can categorize. So that is why we are getting a lot of different benefits. Even it is very difficult to explain. I know that this is kind of a totally theoretical conceptual framework, but without having a proper idea about how these models are trained, people can't understand. It is like a magic. But if you don't know how these values are trained, what is epoch, etc., then you will not get an idea how to come up with a better model. Like if 100 people train a model, you get different values. But very recently, I also understood that why the competition is very high. It is all about changing different parameters. I will explain them. So this formula, same formula, we can train with different parameters. Different parameters mean model parameters. Here, for example, the number of these x1, x2, the number of features. We can change different features and see for these animals and birds, which feature set is going to work the best. So still we can ask the same question in English and ChatGPT will give you the code. I'm going to show you how to get the correct code also. So like that we can get the code. Don't worry about the coding part. Even you can generate any code. Then I will show you how did I generate the code, and I will run and show you what we can do with this. So I think you understood the basics. As long as you understand the basic, you can play with this. Otherwise, it is finally you download something from the net, a code, and you run it. Then you think that is the maximum we can do with this one. And even the model, we need to retrain, rethink how we can further explore. For some data set, it is working perfectly. But when we get more and more data in future, we need to retrain it and we need to come up with better A1, A2, A3, better values for these ones. Please.
So when you're getting more and more data, what happened to the formula? Formula itself change, or I can't understand that formula.
Formula, what I'm telling, in the model file, we can see the values for these A1, A2, A3 like that, right? So
Yes.
now, as of now, in my model, this train model, earlier I trained it, I will give you a chance to run it. So in that exercise, I got only 100 or 200 images, but I have nearly 7,000 images. When I train it for 7,000, then high chances are there I will be getting more accurate A1, A2, A3, right? This is
Yes.
the general one. And maybe if you like here, I think even Siloshan can help me on this. There's a method called transfer learning. So some people already have done this experiment. What you can do, you can download that train model and you can transfer the knowledge already available into your data set. Maybe patients' data in Sri Lanka. So it may be different, like we are a different country, our climate is different, our images may be different, but we can start with that. Even I know some of the researchers, they have applied transfer learning to totally different areas, right? Siloshan, I think you have better understanding about
Yeah, can you hear me?
Yeah, go ahead.
Okay, so I will use this small area to explain that one. Okay, so the idea is that, so let's say if you run one time, right? If you run a one time, the system create a equation like y equal maybe a1 plus a1x plus maybe c or something, right? 1 and a2x2 something like, right? Then when you run the second time, this will be start changing a11 x1 plus a22 something like. So the idea is that let's say if you draw that formula in the xy code screen, the first epoch after first run, you will see a line like this, right? Then the second time, maybe it start drawing another line which is very fit to the data set. Then if you run another one, it will further fine tune. Likewise, so when you run the further epoch, it will start fitting the line to your data. That means like when you start maybe the 100 epoch, so the formula, the variable or the parameter of the formula get further fine tune as Sampha said. It start changing and start adding some more values to fit to the data, what we have inputted, right? So that's how that is the the behind screen when you run the multiple epochs. And also one more comment that regarding that memory, actually there is a kind of an adjusting the weight parameters, right? As to add to the Sampath explanation, it's a kind of an adjusting the weight parameters, right? So adjusting weight parameters is like, it is not kind of an keeping the, what do you call, the keeping the pixel number or something. That is not that kind of work. It's kind of the same way. It is fine tuning the independent and the dependent variable relationship from the equation, fine tune equation, right? So that's the simple and the basic idea. It has a lot of things is happening when we do that, but this is the basic idea. Yes, thanks, Sampath.
Thanks, Silo. So here I want to tell you something. You saw that in Hornbill's picture, there was a tree part there. So when it see more and more hornbills, those tree may be different. So no common thing. It's not a common thing. So in that case, the component or weight here, people call weight also. Now weight and error both are there. I explain it in a simple term. Sometimes this value may be 0. So there's no relationship between the final results from that particular part of the image. I think you got the idea. So I think going into further details, we can explain it maybe another 8 hours. So it's a kind of a area to do PhD actually. So I think this is enough for the moment. I tried my best to cover the simple understanding and the concept here. So now what we are going to do, I want you all to forget about your background. And I know that there are a couple of very professional people here. Forget about your educational background. Some accountants also here. So we'll try to do some codings from basic. So nowadays I'm happy this what do you call, ChatGPT is there. So even there are different GPT. I think you may be using this DeepSeek course. So what I did from my English, I tried to ask this question. I say I need to develop a CNN code. It should extract the images from my data.zip file. I will give you this file and you try to do it. And it's very, very interesting. Like a hobby, if you code, then definitely you will come up with totally new concept and it may be very creative. Don't worry whether the experienced guy can do, we can't do. And I know for sure, even grade 9 student can do that kind of a coding. And I have seen that even in one of the international forum, I saw in one country, grade 9 student won the award in particular category. So they are really smart and they didn't know much about coding. They don't have much experience, but they use GPT in a very professional manner so that they could get the code. So I am trying to explain, like I started developing this exercise. I thought that I don't know anything about this. So like that, I asked this question. It has 2 folders, blah, 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 and develop a neural network model, develop a neural network model and train it with 80% of the data. Now I have, let's say 100 data, then 80% data used to train it. And then show the accuracy. The balance 20% used for testing it and give the accuracy. Something like that I explained. Then upload the image, new image, get the results, give me full code to run in Colab. Colab is one, even I thought some of you guys have not installed any IDE or maybe Python, etc. in your local computer. Then I thought everybody can do the exercise if you use Colab. So Colab, I know it's a Google product. So I think Siloshan and Mahesh has given some examples also in their previous lesson. So everybody knows Colab. So then I need to write a better prompt for this. Then this is the important thing. I think today this is the most important thing you learn. I know my prompt is not good. My English also not good. I tried to get the support from the GPT to write the prompt. Then it gave me a very nice code here. He write like me. I need a complete end-to-end CNN solution. Then it handle 1, 2, 3 like this. It explained everything. And this part I made a little bit change later, and I gave my structure there so that this is the only part I changed, but other stuff it gave provide training process visualization, this accuracy matrices. This is how we check the accuracy of any trained model. And when we give more data, it come up with better F1 scores. That means it covers every corner of the sample. If it is reaching to 99.9998, something like that, that means it's a very good thing. You look at this F1. Usually we look at the model from F1. The accuracy, overall idea we can get from this one. And this accuracy is also there. Sometimes accuracy is good, but the sample is maybe biased. The number of normal images comparing to pneumonia images may be very high. So in that case, this F1 goes down and it gives a proper understanding about the whole picture, the number of correctly predicted items, etc. we can get. So like this, I could write this prompt, and this prompt is not very short prompt, it's a very complete prompt here. I could get all these things. So what I am going to do now, I gave this prompt from this DeepSeek, I gave it into ChatGPT. And ChatGPT happily generated this full code for me. And it asks what to do before, etc. Even it gives code to upload the zip file, but I thought of uploading it manually. So like this, it gave the complete code. Even I can ask some questions like instead of uploading here in Colab, when we upload something, after sometimes it is getting expired, the session. Then I have to upload it again. If you ask the question how to do it using a common folder like Google Drive or something like that, it gives a proper answer. I am not going to show you how to do that because I believe you also need to use your brain and creativity and give the prompt like me and decide how to do this. Right now, what I am going to do, I'm not going to teach you how to write prompts, but I wanted to tell you this is a very good methods of getting the most fruitful output. If you get error message, again give it as error. I also got some errors. Then I think I got some errors. Then I didn't try to correct it myself. I could correct it. Earlier I got another error. So anyhow, I could generate this code and I wrote a good prompt. And the prompt should not be very simple. I need the CNN model. Something like that. If you write, it will not run. So put more energy to write the prompt, and then you get less errors. So I need you all to try to run this one in your Colab, and please give a try, and nothing to lose. So we will do it together. I like if somebody can share the screen. What I am going to do now, I am going to share these two files with you. One is the code which I got from ChatGPT. I want you to do it leisurely, and I will share with you the full code set as well. I will show you the files which I'm going to share with you. I'm going to share with you this code, and you try to run it. Try to run it yourself, and I will explain the code later. Don't worry much about some of the areas, but if you have any questions, you can ask from GPT and it will explain everything. I will explain the code, that's okay, but I need you to run it. To run something in Colab, what you need to do first, I will open Colab from here. You type Colab, and if you have not run any code earlier, you need to give kind of your basic details like your email address, etc. Then here I think Okay, I will open a new notebook like this. You also try to create a new notebook. So I will give you the code and little by little we'll run it together. So not try to open, try to create a new notebook here. New notebook in your drive, it will be saved into your drive and even you can download that. So like this, you try to open, I will close my other stuff. Okay, I will share this path with you. It is a shared folder. So you get this my data for the moment. For the assignment, you get this data. This is a complete set of data. This code is also I included here inside this folder. I will right now share this link with you. So try to get the files from here. I think it should be accessible. If you can't access, please tell me. I am going to do it with you. Probably I will be asking some of you to share your screen so that I can see what is happening there. Probably in my Colab, everything is installed. In your Colab, if something get wrong, then we'll try to find solutions practically. So you come back to GPT and ask the question. So from this folder, you need to get this small data set for the moment. And this big data set, you run it later. And this is my mobile number. You can send me a screenshot and show me that you got the accuracy and you did it in the right way. So send it with your full name. So some of you will get the certificates so that that will be your final assignment. And when you could run it with me, then that's good. Even this recording, you will get a copy of this recording so that you can leisurely look into that, and I'm going to run it and show you. From this folder, you can download. For the moment, you download only this part, and this is, I think, 1 GB. This is 62 MB. This one has the full set of data, and even you can use it for your practical assignment or practical solution as well. So this code, we are going to run it, and now, step by step, I will be helping you. Now, first thing is that you need to come to Colab and we'll start a new here. I'm giving you some basic. So by clicking here, you can change the name of your notebook. I'm going to close this and I will open everything from scratch. Then you will not be confused. So we'll run step by step and see what challenges we are going to face here. So first go to Colab, type here Colab. It's a Google thing, and you can open a new notebook. And this is also not a new thing, very easy to study. By looking at the interface itself, you will understand how we can work with Colab. I need you all to try it, and don't worry about the code much. Let's try this code. I will tell you how to run that code. When you, sometimes it is not displaying this file menu, but if you see this small arrow button, you can see this file menu, and from here you can open a new notebook in your drive, and then you name it like I will show you how to do that. My computer is very slow today. Anyway, you will be able to do that, and I need you all to try it, and through chat you tell whenever I ask question, you can confirm me, we can move forward. Then like this we can rename it. Here you can find a small rectangle kind of a thing here. So if you click it, you will be able to connect to the drive, and here you can see sample data. By right clicking this, you can upload your data. I'm also going to upload my data. This is my data.zip. I'm first going to upload it. So then it will take little time. You can see this small circle here. it will be uploading as a zip file. So if you could come up to this stage, please text me in the chat so that I know that you are also with me. I know you all are professionals, so I don't want to force you to do this, but if you can try this, I want you to enjoy coding. It's my hobby. Sometimes I work whole night and even I don't feel tired. And in the morning, wife brings me the tea, then I understand that I couldn't sleep. So that happens few times. So I want all of you to try. It is very interesting. And when you run something and if you get some output, then you can enjoy that. And nowadays, coding is not a very big challenging task. I'm sure in future, most of the developers will be using already available AI agents to code. Now also we can use AI agents. So I will give you time, and if somebody like to share your screen, I will guide you one by one. You can share your screen. And others, when you complete it, you just confirm me that you could upload the data. At least if you could open Colab, then please confirm that as yes, so that I know that you could open Colab. So as I requested, I shared my number. You can send me your output as a screen print so that I know that you did something. And later on, you can try with the bigger sample so that send me with your full name so that certificates can be issued. So can somebody confirm me where are you right now? Could you download everything, or at least tell me if you could download, or if the download path is not working, then I can send it as a chat. Even I will send it as a chat, then that's good. If somebody feels that it is difficult to connect or something happen in your local environment, so please share the screen. I need you to share it with, not to show others that you are in trouble, but others also will learn something. Because in this industry, especially when it comes to these kind of practical sessions, if you encounter something, from that mistake, others will know how to correct that kind of thing. Today, everything may be running perfectly. For them also, probably it will encounter same problem in future. Can somebody share the screen so that I can see what is happening there? Earlier, everybody started asking question and speaking with me. Now, I think you agree with me, right? I'm not going to give you any big troubles, but I want to help you. This is a practical session. Doctor, please tell me whether you are with me, or do you need more time, or can I move forward? I have a lot of things to share with you, but we have a limited time. I know you are also working. At the end of the day, you are coming for this lecture, but you need to learn something practically. That's why I'm asking. So others, Bimalka, are you okay? Everything seems okay, right, from your side? Mr. Samantha, are you there?
Excuse me, Sampath.
Yeah.
I have encountered some problem. May I share my screen, please?
Please share the screen. Thank you very much.
Is it visible for you now?
Okay. Wait. I can see your screen.
I have encountered some problem here.
Okay, wait. So I didn't ask to run it yet, but anyway, we'll come to that little by little. So wait for the moment. So till others come to this point, I need you to be patient, and then I will run one by one. Then you can correct yourself. Thanks for sharing the screen. So thank you very much. Now I'm not trying to run anything. I want all of you to come to your Colab, change the name, file name, and then upload this file. So up to this point, if you can do that, that's okay. And I did not run any code yet. Even I didn't tell you how to run the code. So up to this point, you all are okay, I believe, right? Is there anybody who could not upload the zip file mydata.zip? Tell me. Can I move forward? So I'm asking from all of you, not from the general comment. If somebody tell me that I can move forward, that doesn't mean others are okay. But if all are okay, then I will move forward. At least tell me if somebody wants more time, tell me. Since I have little time, I will move forward. I will copy this code, then we'll try to run. I don't know whether I will get any errors, but I will try to run and show you, explain you what is happening there. So let me try it. Okay, I copied the code using Control C and Control V. I opened that code and I copied it here. So to run this one, usually we use a shortcut key, that is Shift Enter. Shift and Enter you can put together. So let's see. Now from this button you can see that something is happening. It is working, and when you go down here, little bit, you will be able to, if it's okay, I got a problem here. I got a problem. It says, I think the earlier somebody shared the screen. She also got the same error. Content my data train, that is not found, right? Okay, then what we can do now, there's a problem there because I uploaded this file, but it is searching something like this. So now this is a practical scenario. So then how do we fix this? Now I close all the previous ChatGPT, etc. Now I encounter the problem here. Now I want to show you how to fix this kind of a problem. So I put it purposely. So I need you to get an idea how to correct this when you encounter this kind of a problem. So here you need to ask the right question from GPT. Now, to ask the right question from GPT, what you need to do? First, you need to give this code. This is one input. Then you need to give this error message also. But before anything, you need to understand that what is this error. Please read this error carefully. No such file or directory. Train. It expects a directory like train. I will explain how I did it here locally. If you extract your this particular directory, I will create a folder here. And I will try to explain the folder structure here. Now this is in a zip mode. I uploaded it as a zip file. So here when I extract it, I have created some folders. I will explain those folders as well. My data is the folder structure. Inside that I created test folder and train folder. Inside train folder, I put another two folder, normal and pneumonia. Inside normal folder, I have 80 images here. You can see 80 images are there. So like this kind of a structure I created because I wanted the model to train from the data inside train directory and test the data from test directory. So that is why I gave the special instruction here. When it comes to the prompt, I explain the folder structure as well. You don't need to do everything again and again. Here I gave my folder structure as well. I will share this prompt also with you so that it will help you, I believe. Writing the prompt is important. So it makes our life easier. Even we can do everything from the code as well. But I gave this kind of a prompt earlier. I think I can't send all the details because it limits this one. So anyway, I will upload the prompt to the same location later. For the moment, what I am going to do, I am going to ask a question from ChatGPT how to fix this. Because I understood now this zip file is not extracted. That is why we are getting this error because it tries to create my folder structure. This one is in a zip folder structure. So what I'm going to do, I'm going to give this code so that GPT knows my code well. Every time you don't need to do that. I can even ask how to extract the zip file like this and do that, but I'm telling in case if you get something which you can't identify the root cause, you can simply give these all text errors like this, and even if you don't ask a question, it will identify what is the root cause of this problem. So, okay, how to fix it? Upload files. Then it needs something like this unzip, right? File upload I did manually, but I can use this code and upload the file as well. If I run this code, you will see that it gives kind of, I will try to run this. This is not required actually. It does okay, upload files like this also. Then you don't need to go and click upload button here and upload. By clicking this, you can select your folder and upload it. So for the moment, I will stop that. And then unzip. This part is missing part. So what I'm going to do, I'm going to copy this code and I'm going to add that code in a separate cell like this, and then I will run this code. Okay, then it says upload is not defined. Okay, here the names are different. My data set, here the name is my data set. So this is different. So I can even ask this question again and I can get it from ChatGPT. But here what I'm going to ask, I'm going to give a different prompt here. Simply copy path. I copy this path and I'm telling to GPT like this. I'm going to ask the right question. I need to extract this file in my code. Now it gives me this path thing. I can simply run it. So even you can give this command and you can ask it again and again. But since we don't have much time, I'm trying to run it like this. So now you can see here inside these folders, my data is coming like this. Test train like this. So then we need to check the folder structure here. It goes to my data and again my data is here. So I need to do a small change here. My data like this, because inside my data there's another folder. It is automatically created my data like this. So I hope that this will work. Okay, now it works. So I need you also to try. And what I'm going to do now, I'm going to create this new code with you so that you can run that. I want you to try it. That's why I gave that. Then I will tell here new code, right? I'm trying to show you without using your brain. It is difficult to totally depend on ChatGPT as well. But here you need to try something. Every time you don't get perfect codes, but you need to give a try. So I will share this code also with you. In the chat, I'm sending the new code. So you can run it easily and just try whether it's working. Check whether I could send it or not. I send you the new code and I will upload the new code to that path as well so that nobody will confuse from that. For the moment, use this new code and then try to run it. And if you could run it, please share your screen. Then I will explain the code quickly. I will explain the code. Here now you can see this pneumonia model.h file. So this is the model. I will explain the code. Don't worry much about the code, but you can ask question one by one. I want to give you some basic idea. So here, confirm me if you could run this one. This code, you simply type shift enter so that it will be running. The new code should be running. Hello. If you could run it, please confirm me, right? I appreciate if you can run it and send me a screen print of this final accuracy and the tables, etc., so that I understand. Then at least one person could do that. The first person who can share this screen, I think he's the most smart guy. And earlier somebody tried and who asked the question. It's good that she tried, but I wanted you to not to go fast or not to go slow. So go ahead with me. I will explain the code. If you could run this, then this is real coding actually. Mr. Samantha, are you okay or could you follow this? If somebody wants to share your screen, please share now. If there's any problem, I will fix it. You all agree with me, right? Are you with me or what happened? I can see still some people are there, but I'm not sure whether you are working or got some problems. Please at least chat on the message saying that you are working. Silo, what is happening? I don't know whether others are sleeping now. I think in your lectures, all are coming very active, right? I'm doing kind of a tough coding, probably maybe it's not
Maybe let's see.
time, right? So coding after long working day, it's not good sometimes.
Mm,
But at least we need to enjoy, right? So, like
correct,
when we
correct.
get something run like this, it's happy. Some developers are also here so that they can ask questions. Okay. I think no problem. I understand that some doctors are using their mobile phones, but this recording you will get, and even it is not difficult. I shared the files and everything. So you try to do it later. It's interesting. If you run it, then you really feel that you are working with AI. Using already available tools in the net, somebody has developed. It is not AI. It is how to use a tool. But this is a real AI, real projects. Actually, the file size is not GBs. The size of the file is a small one, I think. Some people get some internet connection issues as well. I don't think it is GB. It is, I'm not sure, doctor, you are using the big file. I wanted you to upload not the big file, this my data file, the small one. It has only, I think, 65 MB. Okay. Computer got restarted. At least one lucky guy should be there, right, Solution? So that we feel that we did something good. If it is the first time they are running a kind of a computer vision thing, then we can happy in this scenario. I want to explain this also. Okay, 60 MB, right? Not GB, right? Okay, thanks. Others, please tell me whether you could run it or you need more time or what happened. I like to know that so that we can move forward or we can wait. Taking little 10, 15 minutes is okay. This is important. If others are busy, that's okay. Anybody can leave, but I will explain this. Then only you will feel that you learn something. Running the code is not a big thing, but understanding the concept behind the code is the most important thing. Then only you can ask the right question. If anybody has any questions, please ask me. Even while you are working, you can ask questions so that I will try my best to answer. Okay. I think I saw a message in the screen. Silo, could you please check this message and advise how to correct that? I think she's in the wrong path. She uploaded the file into a wrong path. Here we can drag and drop the file to the correct path. So how can we move that? Oh, what
I guess he's trying to upload that to the root.
she's uploading it to the root from root.
Yeah, I think he's
Maybe
updating to root file. Yeah,
maybe she can right click and get the path from there. Also, she can extract it. I think there may be rights, no?
yes, yes, yes. He what he can do is he can simply refresh the browser then it will automatically redirect to the working directory. Then he can drag and drop the zip file.
I will show it from my screen. What you can do here, if I refresh it, my thing will be missing. You can highlight this path and you can press enter so that it will be coming to the root again. Or maybe you open a new browser and upload it again so that you can come upload it here. Or else what you can do, from here right click and get copied the path, and your path may be different. I think you uploaded it to somewhere inside the folders. So then you can change the path from the code simply here. Instead of this path, you can paste the copied path by pressing Ctrl V. You can paste it, or anyhow you can paste it like this. So from here you can copy the path and paste it here. So then it also will work. No need to then upload it again. Anyway, that's okay. You give a try, and you got a lot of troubles. Finally, if you could run it, then it's a big achievement. We'll give a try. So for others, did anybody complete this? Or is it difficult? Even I shared the code. What is missing? At least one guy should be able to come up with the final screen print so that we know he's the guy who can identify the structure of the code quickly. Still running, okay. Let's say that's okay. Okay, good. I like to know who's this user. What's the name?
Hello,
Hello. What's your name?
I'm Marcy.
Okay. Thanks, Monkey. Okay. That's good. So we'll wait others also. So give a try. At least one could complete it. I'm happy. Have you done any similar kind of model training before?
Yeah, I have done. I have worked in Colab.
I mean, any
No, I
Uh,
have done anything in image processing or anything. This is my first experience.
Okay, great. That's good. I think Silo Colab may be new to others sometimes. I think another problem encountered. Okay. What is the screen print? Could you copy the path or what happened?
Sampath also, so if they are having some issues of running the file, maybe it taking some long time, so they can just change that runtime environment as well. So you can show it, right?
Yes. She's asking whether this is the right place to copy and paste. Yeah, that is the right place. Please paste the file name there. That's correct. Okay. Now run. It won't take much time. Only 200 images are there, Silo. I could run it in 1 or 2 minutes. My internet connection is also not very stable today, but I could run it.
Okay, so anyway, Sampath, probably you can show that the way, maybe if you want to click that the place which is showing the RAM and disk, the small drop down line. No, the right side, top of right side.
Yeah, here, right? Yeah.
No, right side. Go to the right side. Yes. Click that drop down menu. Yes. So change
Okay.
runtime.
Good.
Change
Yeah.
runtime. Second. Yeah.
Thanks for reminding. Yeah.
Okay, yeah.
I also ran it on CPUs. You can click GPUs.
Cancel it. Otherwise it will cancel it. Yeah.
Again. So if somebody think that you need to run it fast, you can use CPUs, and from change runtime type, you can get it. I think Silo, you did these things right. So this is CPUs and GPUs, so it is much more powerful, and you can finish it quickly. I don't think that it won't take much time even if they use CPUs, but for sure, whenever you run the big sample, you use GPUs. Okay, Malki got the output right. Miss Chetani, is it running or what happened after changing the path?
After changing the path, of course, I think I copy pasted the original code to the middle of the codes.
Oh,
Now
no,
I
no,
have
no,
a
no.
bit of a
No,
duplicate, so I'm trying to get rid of the repasted part actually. So I'm
no, no,
checking the code from top now.
no need to do like that. You just press Control Z.
Okay.
When you undo it, Control Z for undo, so that it should be the same.
Uh-huh. All right. So I should select the whole thing and then do a control Z, is it?
No need to select whole thing. You press
Uh-huh.
Control Z. So if you press Control Z one time, it will undo the last thing you did. But if you delete some other stuff, then probably you will need to do a few times. Or else simply you can copy everything from the text file and paste it here and change the path again. Then it is.
Okay.
We'll give a try. Nothing to lose. So that happens.
Okay. All right. Thank you. So it's little alien to us, I mean.
No worries, no worries. I wanted to break that attitude. Like you all think that
Yeah.
only developers can do that. I want to show you that even you can ask question, you can try yourself. If this is successful, definitely you will be doing more experiment and one day you will become a very good developer. I'm sure.
Thank you. Thank you.
So everybody makes mistake. Yeah. Even I feel nowadays even kids can code because the technology is there, but first time we need to start something. We make mistakes. Through mistakes we learn, but after that the journey is very fast. At the beginning it is very difficult. Even when I am telling Control Z or to undo it, or maybe pressing Shift and Enter, you don't get it. But when you familiar with that, even you don't look at here and there what to do, how to run it. So the small instructions are very important. Then after that, during your lifetime, whenever you run something in Colab, you will be using Shift and Enter to run it. Otherwise, you can run it using this arrow button you can see in the beginning of the code. If anybody like to share your screen, please share your screen. It will help others also to learn something. Ask questions, share your screen. Try to do that. Making mistake is perfectly okay, no problem. So we are here to help you. Even Mahesha, Siloshan can help any of you. That's okay. Even we make mistakes. Even we don't know sometimes how to correct that. But as a team, we can do it together so that it will be more easy. Please advise me, do I need to explain while it is running? You can listen to me. So I think some of you take little more time to run it. So can I explain it, or can somebody confirm whether I should explain the code? I will do it in quickly, and if there's any question, you can text me. I will explain further. I'm not going to explain line by line, but I will give you the basic concept how we have developed this code.
Excuse me, it's Senani here again.
Yeah.
How to run the code? What was the shortcut you said? Command and Shift and
Enter. Shift Enter.
Shift Enter.
Yeah. Otherwise, you can see my mouse pointer here. This is
All right, the arrow.
the arrow. You run it. I'm sure that it will be running now.
Okay, let's see. Thank you.
I'm sorry taking little bit time, but I think since all of you are here, we need to wait a little bit. I am very happy today. If Ms. Shanani could run it, then we know that she's participating very actively. For others, I'm trying to tell you something. If you go to this AI Studio and if you go to this stream, you can ask some questions by sharing your screen. So I'm trying to show you something. If others could get something, you will also learn something. For example, I'm trying to ask a question from this AI agent. Till others complete it, I'm trying to show you that. So I will try to share my screen with the agent like this, and I need to allow while visiting this site my microphone, etc. So that I'm going to ask this kind of question. So you also encounter something like this. then for example, I'm going to ask how to run this code. So it should answer me. Could you please tell me how to run this code in my Colab? I think my voice is not enabled. Let me try it. Could you please tell me how to run the code in my Colab?
Sure. To run the code in your Colab notebook, you can either click the play button next to each code cell, or you can press Shift and Enter on your keyboard to run that specific cell. If you want to run all the cells in the notebook and sequentially, go to the Runtime menu and select Run All.
I think wait. I think I tried to show you how to get the support of AI agent called this is the path you need to go there. AI Studio here. Then you can click this stream. Then you can share your screen from here. And then you can allow your mic and camera to give access to the agent, and you can ask the question. So I asked the same question Shirani had, and I asked how to run it. Then she gave me 3 answers. One is that clicking this play icon. Then she said same thing. I said the shortcut key Shift Enter. Then she said run all. This button also she said. I think these kind of things also will help you. So let's check what's happening now. Silo, what happened here? I can't understand it.
Which one you are asking, Samba?
I got a message in the group, I think, right?
Okay, so unsuccessful. Tell executors to task and previous
Unsuccessful.
execution and the transition. I think if
Error
Senani
message.
can,
you see.
Senani can share the error message, then we can troubleshoot.
Yeah, we can help you if you can
Yeah.
show the error message. Send me a screenshot of the down bottom of the window.
Yeah, again, I repasted and did the same steps. Again, it says run cell, control class center, cell executed since last change, previous execution ended unsuccessfully.
Do you know how to share the screen? Is it possible so that we can?
Yeah, I'm on the computer. I can, yeah,
Yeah.
give me a moment. I'll show
Please
you.
share the screen. I'm sorry from others because we need to get her into the right track. So she's very active, and I think if we could get this run on her computer, then it's a good success. Okay.
I'm doing it with my computer. Is it okay if I send you a photograph of what I see on the screen? It's the same actually, what I shared before.
In this forum, can't we share the screen or what?
No, because I'm joining your conversation through the phone and doing it on my computer, so that is why
From
I
the
can't.
okay. I understand that you are not okay.
Otherwise, I can join the Zoom also from the computer.
No need. We'll do that. At least if you can send a photograph or something like that, then we will
Yeah.
understand. What's the error message there?
It's the same error message I already sent to you. I'll just resend it.
No, I mean, they are like, this is not the error message. So at the end of the code, you can see some errors.
Yes. There was error message at the end. Let me show it. I have posted the error message that I got.
Okay. I got the right. Okay. What I'm going to do, still you are running. Did you run the code which I sent? Okay. Please run this code, right? Not the first one. You run. I send a code. The first code we had a issue, and then I showed how to fix it. And
The new code.
new
Is it
code.
on?
Yeah. I will send it again. So while you are trying to run it again, I will explain the code here. We have a little time. I need to finish this session by at least 10:30. So I will explain the code. So if there's anything, you look at the video and try to run it again. Here from this area, it is all about the available libraries in Python. So which we are using different libraries. And if you look at these libraries, you can find uh, the the model here. There, then layers, etc. Everything we use here, we call it from these libraries. And then the most important part here is that when it comes to model, we have given the instruction to the computer. The model should be like this. So we specify what is the max pooling layer size, and then the activation function relieve, etc. we specify here. So this is all about the model details. And then this is very important point. Even those who know about machine learning also, this may be a very valid point. Even in my final research, I learned this after little time. This checkpoint is very important. What is happening when your model size is very large, or when your data size is very large, it will be saving the best model every time. So here you can see model is saved. So whenever you run it, it calculates the accuracy. After running every instances, it calculates the accuracy, and the best model in every purge it is saving. So whenever you start again running it, and it will not run everything, it will start from this one. So checkpoint mean it is running here and saving the best model, so that you can recall it in the next run if something happened in the middle. So then after that, this accuracy, etc. is important. I will explain it. So accuracy related graph we can get from here. And this ROC curve is also important thing. And curve related instructions are going here. And predicting image, that is for, like earlier, we use this train data to train the model, and to test the data, we use this data, test data. So for training and testing, it is using like that. So I will try to explain how to get the accuracy. When it comes to test data, from these folder names, it knows that these are normal data, these are pneumonia related images. So what it is doing, it get this data and it send it to the machine learning model, and it get the predicted thing. So accuracy is calculated. Now it already knows what is the actual data, and it compare the accuracy with the predicted data. So here, while training, it calculate the accuracy. Here, this is how accuracy is varying. This is validation accuracy. Again, 80% data it used for training, 20% data it used for validation. So during the validation period, the accuracy goes like this. So this is a small amount, and everything not in the perfect manner. Training lost and validation lost also, it is showing like this. So this is the important part. Here, if you look at this carefully, if you don't understand, you can copy this and ask further questions from ChatGPT. If you look at this, now these are the accuracy measurements in general. So precision, recall, and F1 support. So you can see in normal data, and this one, the accuracy and detail separately, and this is called confusion matrix. So if you see this area, this is the most preferred area. Like here, predicted as normal and actual as normal is 10 out of 80. I think 10 is predicted as 10, normal as 10. This is preferred accurate area. And here pneumonia, it is predicted as 20, pneumonia actual also 20. But this 10 is problematic. What is happening there? Actual is normal. Actual images are marked as normal. Under normal folder, it is found. But predicted as pneumonia, which is wrong. The model predicted as pneumonia. That is wrong. But actually, it is normal. So this 10 is incorrect. So this is why the accuracy has become like accuracy is 75%. So 25% error is there. So when you train more and more, this will be corrected. It has not seen some of the images. That's why it is marking these as wrong. This is also wrong. This is pneumonia actual scenario, but predicted normal. So this is 0. That's mean no error here. So now our ROC curve that covers only 90% of the curve. That's mean our data is not sufficient and it will not cover everything. So here F1 score comes as like nearly to 1, 99.995, something like that. If it is coming, that's mean we have used lot of data and accuracy is also good, and it represent different categories like normal and pneumonia. So then you can get some idea about the accuracy. Here accuracy is only 75%. If you run the bigger sample which I gave you, then definitely this R1 would be very close to 1. So I think I want to explain only up to this for the moment. And if there's any questions, you can call me or text me so that I will try my best to answer. Today you did or tried something. That's the important thing. And I wanted to show you that even with ChatGPT, given the right prompt, you can get the code and run simply. In the beginning, it will be difficult, but when you are familiar with that, it will be very easy. So I'm going to stop at this moment, and thank you very much all. If you have any questions, you can ask. Others you can leave, and you will get a recording as well, so that you can listen to that and try again the same thing. Okay, I think you don't have any questions, right?
Thank you. Thank you very much.
Thank you very much, Doctor. I'm sorry about the delay. So anyway, it's a good session. I had a very fruitful session. Thank you very much for your participation. So if there's anything, you call me or text me, so I will help you. Thank you, everybody, and good night.
Thank you. Good night.
Thank you.